And then the next step, once we have the project, we need also to define some requirements for our project. So we first need to insert new specifications, in that case for antenna placement. Then we will define some, insert some specifications for mechanical. So for design requirements, that means, for instance, where the antenna will be located. Then we will also have some specifications or requirements for electromagnetic performance. Then we again insert some design requirements. So the antenna locations are placed here. Then a requirement for the geometry simplification. And then we add the specifications for the installed antenna itself in terms of scattering parameters or VSWR, then co-set interference, RF systems. And then we can also define some parameters here for the number of positions we want to investigate, where we have different antennas located on our aircraft. We can also define a KPI for the S11. And then we can also add the RF system parameters in that requirements dashboard here with some value. Then the glide slope antenna sensitivity. And of course, in general, for a real application, you will have much more requirements. So it's just for demonstration purpose. But I think it gives you already a good idea of what you can do with it. And with that, we need now to move over to Naomi, who will take care as the CAD designer about the aircraft model aliasation. Naomi, can you please take over?
Yes, thank you, Marco. I'll be sharing my screen. Yes. Hello, everyone. I am a CAD designer here. And once Marco defines a project task and assign it to me, I receive a notification here in my tenant saying that a task is assigned. And after that, I open the model and perform the task aircraft model idealization, which involves 3 steps here: CAD simplification and parametric axis creation, volume extraction. CAD simplification and volume extraction are required to simplify the model so that the simulation time will be reduced. And the parametric axis is created to locate the antennas at that location on the aircraft. So let's go through the video to understand it better. So the first step in CAD simplification is to remove the openings of the aircraft, which is the windows and the doors, for which we require an application called geometry idealization. We click on the compass and search for the application and click on it. We can verify if we are in the app by checking on the top right corner. And to remove the window, we just have to select the face of the window. And since these faces are not connected, there is a application that is the tangency propagation option. If we select this, all the faces which are connected to this face will be selected, so that we no need to select all the faces one again and again. Once we select this and click on OK, the door is removed. And to remove the window, since it is already circle and connected, we no need to select the tangent propagation. We just select the face and click on OK, which removes the window as well. Similarly, we have to do the similar operation multiple times to remove all the windows and doors. And now to simplify it further, we have the wings here. And as we can see, this is a separate part in the assembly. So we can just hide it to remove it from the simulation. Now we have the simplified geometry in our hand. The second step is to create the parametric axis, for which we first have to create a point at which location we want the axis. We first select the curve and we define where we want the point. So the point has been created. And since we want it parametric, we also create parameters of the type length. And once we create it, it is added in the tree under parameters. So for simplification purpose, we rename it. And we are planning to have 4 locations on the aircraft. So we have to create 4 parameters. 3 for the VHF antenna on the top and 1 for the glide slope on the bottom. So we are creating 4 parameters. Now we have the point created and the parameter created, but there is no link right now. So we are opening the point and giving or assigning this parameter to this point to make this point as parametric. Similarly, we are creating other 3 points and assigning the parameters that we created in the length. We select the curve and say that we need at the end of the curve the point, and we assign this parameter in the length. And for glide slope, as I said, it will be on the bottom side, so we are creating the point on the bottom. Yeah. Now we have four points created on the aircraft. To create the axis system, first we need to define a default axis system as a reference. And then to create on the aircraft, we use the points that we created as the origin. So we select the origin and select the point as the parameter. Similarly, we create axis at other 3 locations by using the points we created. If you see, there are only 3 axes on the aircraft, but I told there will be 4 because these 2 axes, 1 and 2, are in the same location. Since they are parametric, we just need to change the parameter value to move it to the location wherever we want. So now the 4 axes are created. Next step is to extract the exterior volume, for which we hide the axis we created. And we go back to the same app we used earlier, which is geometry idealization. And here under idealize tab, we go to the exterior volume option and we select whatever the parts we need to extract the exterior volume. Here I am selecting all the parts and selecting OK. And here we have the simplified model with the axis created. So this model will be used for further simulations. Those are coverage analysis and the interference analysis. So for explaining these simulation things, I hand it over to Harvinder. Yeah, thank you.
Thank you, Naomi. Welcome, everyone. So my name is Harvinder. I'll play the role of the EM simulation specialist for this workflow. Let me start with sharing my screen. Can you see my screen?
Yes.
Yes.
Yes. Okay. So once the CAD simplification has been done, the CAD designer makes the task in the project management tool as completed, and my task in the project management tool is being moved to do. So I get a notification that I can continue with the antenna placement workflow. So I will today present about 3 steps in this workflow: the antenna installation, simulation setup, and coverage analysis. First, let's start with the antenna installation. So once we have the simplified aircraft geometry, we can proceed with the antenna placement study using the antenna placement app. We can find this app under the compass. In the app, we will install VHF antenna and the glide slope antennas on the aircraft. We'll start with defining the simulation model by adding the aircraft assembly as the platform. Here you can see the contributing shapes manager lets us select only the simplified aircraft geometry that is relevant for the simulation. Similarly, we will also add the VHF and glide slope antennas to the simulation. So these antennas are CST Studio Suite projects that have been saved to the 3DEXPERIENCE platform. They represent the antenna in a freestanding environment. We have used antenna makers to design these antennas, and their uninstalled performance has been validated in CST Studio Suite.